All right, so we're going to start watching some movies for about 10 minutes. Who has seen Inception? Or who thinks they've seen Inception? There it is. We're going to talk about the concept of recursion today. And the idea of recursion is that I have a program that calls itself. So it's like I'm in a program within a program within a program within a program and so on and so forth. And I was like, what's a great movie just to kind of demonstrate this? And it is the concept of it is Leonardo DiCaprio in Inception, because you have that dream. No, I don't want to play right now. You have a dream within a dream within a dream. So I think just to kind of get our juices flowing a little bit, we're just going to start watching this for a little bit.
They say we only use a fraction of our brain's true potential. Now, that's when we're awake. When we're asleep, our mind can do almost anything.
Such as?
Well, imagine you're designing a building, right? You consciously create each aspect. But sometimes it feels like it's almost creating itself, if you know what I mean.
Yeah, like I'm discovering it.
Genuine inspiration, right? Now, in a dream, our mind continuously does this. We create and perceive our world simultaneously, and our mind does this so well that we don't even know what's happening. That allows us to get right in the middle of that process.
How?
By taking over the creating part. Now, this is where I need you. You create the world of the dream. We bring the subject into that dream, and they fill it with their subconscious.
How could I ever acquire enough detail to make them think that it's reality?
Well, dreams, they feel real while we're in them, right? It's only when we wake up that we realize something was actually strange. Let me ask you a question. You never really remember the beginning of a dream, do you? You always wind up right in the middle of what's going on.
I guess, yeah.
So how did we end up here?
Well, we just came from the,
Think about it, Ariadne. How did you get here? Where are you right now?
We're dreaming?
You're actually in the middle of the workshop right now, sleeping. This is your first lesson in shared dreaming. Stay calm.
That's pretty much all I needed to show up for that one. The idea is that, like, when you call a function within a function, that's what's called a recursive call. And it's kind of like the idea is kind of like, how do you know which layer that you're at, right? Think about, in terms of Inception, Leonardo DiCaprio is a dream within a dream. At this point, in this particular clip, he's inside of a dream. How does he know that he's there? Like, and how does he know if, like, he's still dreaming or if he's not there?
This is a little spinner.
Yeah, and in the movie it's called a totem, right? The idea is that I know that I'm outside of a dream and I'm in the real world when I spin the totem and the totem falls. Whether or not the totem is actually the totem, the spinner is actually the totem, is a thing up for debate. But the idea is kind of like, you need to know where, if you're going to call a program within call a program within a program and so on and so forth, you have to know what layer that you're at. How do you like, let's say Leonardo DiCaprio is in a dream within a dream within a dream within a dream. How does this person go from the fourth layer deep all the way back out to the first layer?
Well, whatever they call it, I can't remember what they call it, but they like fall and hit the ground or something.
Pretty much.
Feeling a fall.
So once we've made the plant, how do we get out? I'm hoping you have something more elegant in mind than shooting me in the head.
A kick.
What's a kick?
This, Ariadne, would be a kick.
That feeling of falling, you get the jolts you wake, it snaps you out of the dream.
So the idea is kind of like, when I'm all the way, if I call a program and the program calls itself and itself and itself and itself, like, it'll continue doing that forever, and you will never be able to kind of kick back out unless you have what's called an escape case. And just kind of keep these ideas in mind. We're going to actually go over it in just a little bit. But you need an escape of some sort. And then what does it look like? Like, what does it look like for Leonardo if he's 7 dreams in and he needs to kick himself out all the way? So that's kind of like what happens with your That's kind of what happens with your recursive call as well. You're the most deep, so you kick out of that one first, and then you kick out of the second one, you kick out of the third one, kick out of the fourth one. And this clip's a little bit longer. It's about 3 minutes, but we will kind of watch this in action, and then we'll get to actual coding. Why not?
I know you were disappointed. I come to you. I was disappointed. But you tried. The kicks. I chose the wrong thing. Very epic movie. The idea of that is the idea of that is like they are all the way deep into this point, and similarly to the program that you're going to start writing in just a bit. If you're all the way this deep and you have to get all the way back out to the top, they have to kick out of the bottom before they can go up to the next level, to the next level, to the next level, and then finally wake up in the real world. We're going to do a quick exercise here. You two are already familiar with it, but I'm going to ask everyone to stand up for a second, push in your chairs. And Rod and I are going to organize people by height. So go ahead and, actually everyone pretty much knows their height. Why don't you line up in height order? Okay. Now, if I asked everyone to face this front of the room, and let's pretend for a second, look directly into the back of the person's head right in front of you. And imagine that you can't see anything else besides the back of the person's head in front of you. How would you know like what layer you're at inside of? Unless you're the first person in line, you don't know what place you are in line, right? Obviously you do, because this is, you know how many students there are and how many of you guys there are and how many what space you're in. But if I asked like Peter in a metaphorical world where in a hypothetical world where he can only see the back of Taylor's head, how does he know what space he's in? You don't. It's not possible, right? So what would happen is like if I asked somebody what space they are in line, who's the only person who knows how to get out of line? Who's the only person who can say like, I know what place I am? It could be you. There's nobody else. Especially if you're the last person in line, then you'd actually have. It's actually the worst spot because you have no idea how many people are in front of you. No, I'm saying in an ideal world, in a hypothetical world, if you can only see the back of the person's head in front of you, right? So how would we figure this out? How would Alex know like what space he is in line if he can only see the back of Peter's head? Like what question would Alex need to ask? What's that?
Where am I?
Where are you? Is actually.
Where are you? Yeah.
Where are you? What place are you in line? And if the person in front of you doesn't know, what would they have to do? Yeah. And then at what point would that would have to continuously run over and over and over again until a certain case has been met? And that specific case is the first person, where it's like, I don't see anybody in front of me, thus I must be first. So I'm going to start with Deja, and we're going to go up the line. And just kind of like, again, this is kind of like a silly thing because there's only 5 of you. You know exactly where you are. But in the case that you could only see the person's head in front of you. So starting with Deja, you're going to have to ask the person in front of you, do you know what place you are in line?
So ask Alex,
Yeah.
do you know what place you are in?
No. You know what place you're in?
No. Do you know what place you're in?
No. Do you know what place you're in?
Yeah. First.
Okay. And then?
Peter, I'm in the second place.
I'm in third place.
So, okay, you can kind of take a seat. Kind of. All right, so I'm going to create this file called recursion.rb. And basically what you need to know about recursive calls is that it's a function or it's a method that calls itself over and over again until a certain case is made. You can kind of think of it in the 2 cases that we just saw. The first one that we just did was, you don't know, like, it's basically like, the problem was I'm trying to figure out what place I am in line. And the only way that I can do that is asking the person in front of me, do you know what place in line you are? And then that happens over and over and over again until a certain base case has been hit. And that base case was the first person in line. The first person in line knows that I'm the first person in line. Thus, I can turn around and say, like, I'm the first person, thus I must be the second. You turn around, you keep telling that person over and over again. So the base case for Inception, for the movie, is basically the totem, the spinner that you spin will actually fall. That tells you that I'm actually out of the dream. And like, how do I kick myself out of each part of the dream? Is that I say, like I have to feel like I'm falling the entire time. So again, the 2 things you need to know about recursion is that it's a function that calls itself. So if I have a method called, let's say, countdown recursively, it's a method that calls itself. So somewhere inside of countdown recursively, I have a countdown recursively. This is the definition of a recursive function. It's a function that calls itself. Anything you can do iteratively, you can do recursively, and anything you do recursively can most likely be done iteratively. So if I wanted to create a function that basically counted down from 5, 4, 3, 2, 1, and 0, I can do that iteratively. Obviously, I can do def. Let's do countdown iteratively, and I'll start with starting number. So I will just do. Actually, let me do this in JavaScript because it seems like more people are happy in JavaScript. Recursion.js. So if I have a function
called countdown iteratively. Starts with a number. All I have to do is start a for loop, which starts at var 1 equals num. As long as number is greater than 0, I can subtract a bunch of stuff. I'll just do console log of I, and then console log liftoff. Right, so push this to the side here, push this to the other side, list everything. I'm going to run node recursion.js. Uh-oh. Nope, that's not it. Greater than 0. Nope. What's going on here?
Oh, because I equals the num, so it's no.
Starting at 5. Oh, I'm sorry. It's I is greater than 0. My mistake. I put num is greater than 0. And since I start at 5, 5 is always going to be greater than 0. So I can do this iteratively. I started at 5. I said as long as it's greater than 0, I'm going to subtract 1. And once it finishes, I can do liftoff. 5, 4, 3, 2, 1, liftoff. This is to do this iteratively. If I were to do this recursively, I'm going to create another function. I'll call this countdown recursively. It starts with a number. I'm going to just console log the number here. And I'm just going to say if num is greater than 0, I will do countdown recursively num minus 1. Else, we'll console log liftoff. Let's just see if this works first before we do anything. 5, 4, 3, 2, 1, 0. We'll just make this greater than 1. 5, 4, 3, 2, 1, liftoff. These two are doing exactly the same thing. Remember that everything that you write recursively can also be done iteratively and vice versa. So remember, a recursive function is a function that calls itself. So you can kind of see if I've defined a function here, and right underneath it I called it again, that's automatically a recursive function. I'm calling something within itself. The second thing that you need in every single recursive method is basically saying a base case, some sort of condition that has to be hit. Otherwise, you will continue going on forever. You can kind of imagine if I did not have this num is greater than 1, it would just constantly print out. So if I didn't have this if loop here, and I just said console log the number and then count down recursively -1, it would just keep going forever. And at a certain point, this is going to blow up, and my computer will might need to restart. We'll find out. So this will go on forever. Actually, it only went out 17,000 times. And then at a certain point, it says maximum call stack size exceeded. Kind of like what we saw a little earlier, stack level 2D. It means it's called it so many times that with no end in sight, that it's kind of like, if we continue, then we're going to use up all the memory on your computer. The memory on your computer is going to blow up, and then your computer is going to shut down. And that happens more often than you might think. So with that, we need an escape case, because you can't keep going dream within a dream within a dream within a dream, because that's what happened in Inception. Somebody wakes up. I think the whole premise is like this. The older Japanese guy, he's like, I've been here for like 200 years or something. And he's like, actually, I'm here to rescue you. Like, this is not real life. Real life is actually on this plane or something like that. I'm here to take you back. So it's like you can't go all the way deep and then have no way to get back up. So instead, what I have here is a base case. Base case being like this: once this certain condition is met, then I will stop running it altogether. And you can kind of see I have a base case where it's saying like, only execute this if the number is greater than 1. Otherwise, do something else. So what are the 2 things I need in every single recursive call, Deja?
The base case in which you calling a function within a function.
Yeah. What's a base case?
Base case is a condition that has to be met in order to escape the call stack.
Yeah, it's called base case. It's also called exit case, also called escape case.
Which is number greater than 1.
Yeah, basically. No, it's actually if it's not greater than 1.
Okay, not. All right, yeah.
So, all right. So another concept that we want to kind of be familiar with is this idea called a call stack. It visually looks a little something call stack pancakes. Okay, I'm just going to put this up there just so everyone is hungry. But I promise there is a good reason why we have this up here. You can kind of imagine if I had, you can ignore all of this right here. But if I called like this recursive function without any sort of like escape case, this will execute, then it'll call something else, then something else will execute, and then something else will execute, and it's kind of like dream within dream within dream within dream within dream. So basically what happens is when you call this recursive function, it puts it in the call stack, and it puts it at the very top. Then it'll, if you call a recursive call again, it'll put another one all the way at the top, another one all the way at the top, and another one, and another one. You can think of it if you were making a stack of pancakes. Every single time that you call a recursive function, it's stacking another pancake on top. Now the question you have to ask yourself is, how do I escape, and in which order does it escape in? So when you create a stack of pancakes, what's the first pancake that you eat? The top one, which is the last one you actually created. So what happens is when you create a function, a recursive function, and you call it, it's going to be actually dream, and then if you want to make another one, another dream, another dream, another dream, another dream, another dream, until a certain condition has been met. At that point, when you want to start eating, that's when the call stack is going to start executing. It's going to execute the top one first, which is the most recent pancake, and go all the way down. So it's like last one in is the first one out. That's a little bit of a conceptual thing. So let's create one recursive function. And the challenge for us, and we'll just do a little bit of mob programming here. We're going to write a recursive func method that sums up all the numbers in an array. So if I have the numbers 1, 2, 3, 4, 5, my method in the end hopefully will be like def recursive sum of array. And I hope this will give me 5, 1, 2, 3, 6, 10, 15. So recursive sum. It's going to take in one argument called the array. We'll just call this numbers array. And then I know I need two things. I know I need my escape case, and then I need my recursive sum. I need to call it again with something. So how do people envision that we get started? Should we do some pseudocode, do you think? Should we just jump into it? It's up to you.
Start with the escape case.
Yeah, let's start with the escape case. Like at what point do I stop doing, like, do I stop executing things?
0, 3.
Yeah, that's actually a good one. So I'm just going to be like return. Let's write the pseudocode, like return escape here. When numbers array is empty, we're done. Okay, and then the second thing you said, the second thing we always need is If we're calling a recursive thing, a recursive method, we have a function within a function. These two names are going to be the same. All right, what else? What do you think my next step is going to be? What's that?
We're not popping them off.
What's that? We could pop them off. It's up to you.
Well, I just saw. I was confused by the empty. The numbers are empty.
Yeah. So we're
reaching the end of the link.
again, we can do these things iteratively or not iteratively, right? So actually, that's a good point. Let's do this iteratively first. So no recursion quite yet. We have this array. We have this array 1, 2, 3, 4, 5. And we're going to do sum iteratively with numbers array. How would I do this just to start with? Yeah, we could just do numbers array dot each do number because we want to be descriptive. And then what?
Just want to have some variable.
Okay.
And then just do sum equals or plus equals the number. Set sum equal to 0.
And then at the end, I'm just going to return sum, right? So the idea is I want to iterate over every single one of these numbers, and I just want to add one to the other. So if I told you, Peter, here's 5 numbers in an array. Can you add them all up for me? You're like, of course. My brain works like 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15. So that's the answer to this is 15. And that's kind of what we did here. We started our sum at 0 because that's kind of like our output. We're iterating over each one of these numbers arrays, every single one of these numbers. So the first time through, number becomes 1. The second time through, number becomes 0. And I'm just adding on to that sum. And at the end, I'm just pushing out the sum. Let's just make sure that this works. And Ruby recursion.rb. That did not do what I wanted. It didn't print. And 15. That's what we expect. Anything you can do iteratively, you can do recursively. So we're going to comment all of this out for right now. And we're going to, instead of going through every single one like this, we're going to do this recursively. So 2 things in recursion. 1, we need the escape case. Like, at what point do we know that we're finished with something? And then second, I have to call the method within the method. I call a method within itself. Dream within a dream kind of thing. So ideas? How do I get started?
You want to write the escape case first. Yep.
Cool. Yep.
Numbers array dot length. It's 0. And return one. I guess you should go 0. 0 to be a sum.
So it's like that?
Yeah.
Okay. It's not. It's fine. Yeah. So if I'm saying if the numbers array dot length is equal to 0, return 0, and then I'm done. So this is my escape case. This is the point where I know I'm not going to execute out anymore. Okay. And then I somehow have to get the numbers array shrunken down a little bit each time. Thoughts?
Maybe do like numbers array 0 plus numbers array 1, and on shift. Okay, then you have to do 2 of them.
You have to do 2. What else?
I mean, that's you could do numbers array unshift. I mean, return recursive sum like here, and then call
Like still have to create like a sum, so it'd be like
pop off or unshift whatever you would do from the array. You call it down. But yeah, you need a sum, so it'd have to be
You use like numbers array dot slice one.
Yeah, you need a first one. You're right. You need the first call. So return numbers array plus. So I mean, before the recursive sum, you need like return. I mean, part of that same statement, like a return numbers array dot pop and plus recursive sum, and then call the plus whatever they call to the recursive. And not return second.
Recursive sum of
whatever. I mean,
okay.
I think you have to the pop. Yeah, there's modifying this.
Let's see what happens. Nothing. Okay, that's not good. Yes, probably. True.
Yes. At least it's not false.
That's because it equals. I mean, well, that's good. Yeah.
Wait, this worked? I was actually pretty certain it was going to blow up.
Because it modifies it, I guess. So it works.
Oh, that actually does work. No kidding. No kidding. That's pretty clever.
Right?
Yeah, I see it now. Can you walk us through though? I'm pretty sure some people are a little lost.
Okay. So basically, at the beginning or the end of the stack.
So from start to finish.
Okay, so the first call is gonna pop off the ends of the 5 number array, so 5. And then
So let me just move this down so we're talking in real terms. So the first time through, this condition is not hit, right? Because we got a length of 5. Okay, so the first time through, we get numbers array. So you said 5,
yeah,
plus recursive sum of 1, 2, 3, 4 because you popped it off, right? Okay, and then the second time you're saying what would it be?
4.
4, 1, 2, 3, and then 3 and 2, right? 3, 2, 1, and this would be nothing. And then it would go through one last time. This one would execute, right? And then this one would return 0 because the last one is actually, the length is 0. So it would just be, last time would be 0. That is pretty clever. All right, so just to kind of reiterate, because I think, yeah, it'll be better when we start actually working on this. But a recursive method, again, a method that calls itself and has a base case to escape at a certain point. This one in particular, the base case was if we have nothing left to pop off, if we have no numbers left in the array, we're just going to return 0. We don't have to go any further than this. So this is our base case right here. Little trick that I commented on some people's pull requests. If you have an if statement with just one thing inside of it, in Ruby in particular, not in JavaScript, I can just do this. Basically, return 0 if the numbers array.length is equal to 0. It's a little trick just to shorten it down to one. If you have one condition, like if this, that, that's it. No else if, no else. Like if it's just if this, then that. Okay, so I have return 0 if numbers array length is equal to 0. All right, and then I have this recursive call here because I have recursive sum within recursive sum. So I'm going to return pop, which is the last number. Let's actually see pop in action. So if I have 1, 2, 3, 4, 5, and I set that equal to A. If I do A.pop, my return is going to be 5, and my original array also gets changed as well. So I have array numbers.pop. So the first time through, I pop off. This is equal to 5 because I pop it off. Then I call recursive sum with the remaining 4 numbers. And then the second time, basically when this is called, I pop off the last number, it becomes 4, and then I have 3 numbers remaining. This right here becomes 3, 1, 2, and so on and so forth until we get to the very end. We get to the very end, we're passing an empty array, and then at that point, the numbers array.length is equal to 0, so I return 0 at that point. Then I go back out. Then I go 0 plus 1 plus 2 plus 3 plus 4 plus 5, and then we get 16.
What happens if now that you're done with that, if you print array at the very end?
Like this?
No, like outside, like after the call to the function. At the very bottom. Is it destructive or like?
It's destructive.
It's destructive.
Okay, I was just curious.
Yes. So again, we go all the way down. We hit this base case right here, and this is equal to 0. So the result is that this now becomes 0. This becomes 1, so it pops up to here. This one becomes 3, pops up to here. This call becomes 6, pops up to here. This one becomes 10, pops up to here. And then we just do 5 plus 10, that gives us 15. Any questions on recursion? Yep.
In JavaScript, would that still be destructive though?
Pop is destructive, I think, in all languages.
Even when called within a function?
Let's find out. Let's say our array equals 1, 2, 3, 4, 1, 2, 3. Array.pop. Yeah, it's destructive there as well.
I mean, when called through another through a function, you pop off of the local variable to that function. In JavaScript, does it create a new instance
Let's translate it. I'm not positive. We'll find out.
For some reason, I was thinking Ruby acted differently. You know?
You're talking about pass by value versus pass by reference?
Yeah, that's what he's talking about.
Let's find out. Let's translate this real quick. So function that takes in this. We'll just move all of this garbage in here.
JavaScript is definitely better. Yeah, if you set 2 arrays equal to each other, it's just a pointer.
Well, that's in JavaScript.
Okay, let's see. I'm going to translate this. If numbers array that length is triple equal to 0, return 0, and then
Using parentheses at the top.
yeah, return. I think this will work on its own, right?
Use your array.
Oh, you're correct. Good call. It still works. I'm not sure if that answered your question.
Then print number array.
Down here?
At the very end.
Oh no, outside of one.
Outside the function. Like here?
Yeah, after the call, just to see if it's destructive.
Oh, it is.
Yeah.
Yeah, it definitely is.
Yeah.
It's empty. Cool. Let me stop.